Okay, everyone here? Okay, so today we're going to do experiment 5, okay, which is the investigation of nucleophilic substitution reaction. So in the previous synthesis experiment, we have seen how we do organic synthesis for SN2 mechanism. So today we are going to investigate a different mechanism via kinetic studies, okay? So you have done a kinetics experiment before, right? In experiment 3, what are the important aspect of a kinetics experiment that you have learned or you can recall? Concentration of a reactant. But in terms of your techniques, what do you need to take special precautions? How you perform? Remember what was the last kinetic experiment? It was on what? At regular interval, you take out aliquots, right? So you repeatedly perform a particular technique, right? And then you quench. So what was the thing that you need to take note of? Titration. And when you repeatedly do something, what else? Isabel? What do you need to take note of when you repeatedly perform a particular technique? The conditions must be consistent, right? You must be consistent in the way you perform a technique, right? So today we're going to investigate two things about how we perform SN1 kinetic studies. Okay, part one is going to be concentration effect. So we're going to investigate the concentration effect of SN1 mechanism. Part 2 is on solvent effect. All right. So when you look at page 29, okay, page 29, you see that we have reagent A and mixture B. So reagent A is basically different concentration of your substrate, T-butyl chloride. Okay, so 3 mL of 0.1 molar, 3 mL of 0.2, and then 3 mL of 0.1 again. Basically, we are varying the concentration between 0.1 and 0.2 molar. Okay, so that you just use a micropipette. Just a quick recap on your pipetting technique that you have learned in year 1. Okay, so this is to tap on your prior knowledge. So first, we are using each group of students today will take a pair of micropipette, the 5 mL and the 1 mL, right? So the 5 mL micropipette, make sure you look at the maximum volume that you are able to pipette, that is 5,000 microliter. So if you are supposed to pipette 3 ml, what should you read? 3,000, huh? Okay? So don't overturn, all right, the micropipette. So 3,000, you pipette the corresponding reagent. So when you take the reagent from the bottles at the side there, okay, you basically pour out a bit into the beaker first. Don't pipette directly from the stock solution, okay? So after you pour out, you bring back to your bench, and then you just use a micropipette and then transfer to the flask, okay? So when you pipette, what else must you take note of?